Looking at this problem, we read the following. How much in pounds of chocolate to get 40% of cocoa and chocolate mixture of 60 pounds, where a baker has 20% milk chocolate, 75% of dark chocolate. Baker needs to mix the milk and dark chocolate together to get the mixture of chocolate. Some of you are wondering on how we can solve this word mixture problem. Hi, my name is Patrick, and welcome to my channel. We will go through this problem. I'll show you how we can solve this and some good practices to help us solve problems like these. And we will check our answer at the end. So let us continue. First, if you think you can solve this problem, please pause this video and try it on your own. Now let us continue. A good rule that we can follow to solve any word problem is to read the word problem at least 3 times. This is to make sure that we understand that what the word problem is asking us to do. We don't want to go off in the wrong direction and waste our time trying to solve the problem incorrectly. Here we will read the problem again. How much in pounds of each chocolate to get 47% of cocoa and chocolate mixture of 60 pounds? Where a baker has 20% milk chocolate and 75% dark chocolate. The baker needs to mix the milk and dark chocolate together to get the mixture of chocolate. So reading the first sentence in the problem, how much in pounds of each chocolate to get the 40% of cocoa and chocolate mixture for 60 pounds? Where we want to get a mixture of 60 pounds of chocolate to have 47% cocoa. The next sentence in the word problem states that where a baker has 27% milk chocolate and 70% of dark chocolate. So how many pounds of milk and dark chocolate will the baker need to make 60 pounds of the mixed chocolate? In the final sentence, the baker needs to mix the milk and dark chocolate together to get a mixture of chocolate. This reinforces the problem where we want to find the pounds of milk, chocolate, and dark chocolate the baker needs to make the mixture. We should have enough information to solve this mixture word problem. Here we can make a table to represent this problem. We should make a table when we're trying to solve problems like this, like mixture word problems. This will help us in picturing the problem and seeing what we can do to solve problems like this. The information that we have are chocolate type, amount in pounds, mixture of cocoa. In the first row we have X amount in pounds of milk chocolate at 27% of cocoa. Next row we have the Y amount in pounds of dark chocolate at 75% of cocoa. And finally we'll have 60 pounds of chocolate mixture at 47% of cocoa. As we can see that we have set up our table the data for this mixture word problem. Percentages are an important part of math as we deal with this every day. Many mixture problems use percentages, as there are interest rates like in loans, savings accounts, mortgage rates, and so forth that use percentages, where a loan can have an 8% interest rate. Sales also use percentages like this item is 40% off. Mixture problems of course use percentages. This milk chocolate has 27% cocoa and so forth. We can break down the percentages into fractions such as 27% by making the fraction of 27 over 100 to make the fraction of 27 divided by 100. And percentages can also be changed to a decimal by shifting the decimal point to the left by 2 decimal points, and we can get 0.27 as a decimal, was a percentage of 27%. We can now get the equation for each of the chocolates, and we see that 27% of cocoa for X pounds of milk chocolate. Here we get 0.27x as the equation. Next we have 75% cocoa for the Y pounds of dark chocolate, and we get the equation of 0.75y. Finally, for the chocolate mixture, 47% of cocoa for 60 pounds, here we'll have 0.47 times 60. As we can see that we have two unknowns, amounts of milk chocolate, X, and dark chocolate of y that we need to find the amounts for the solutions to this problem. From the table that we have created to help us solve this problem, we can now come out with the equations to solve this word mixture problem. To say that we should use a table to help us visualize this mixture problem. So we have the first equation, which is x plus y equals 60 from the first column, the amount of chocolates. This is where we have x amount of milk chocolate plus the y amount of dark chocolate equals 60 pounds. The next equation is 0.27x plus 0.75y equals 0.47 times 60 from the last column of equation. This is after we convert the percentage to a decimal number, and since this is a mixture problem where 27% of milk chocolate plus 75% of dark chocolate equals 47% of 60 pounds of mixed chocolate, or 0.27 of milk chocolate plus 0.75 of dark chocolate equals 0.47 times 60 pounds of mixed chocolate. We got our two equations that we can now begin to solve this problem. We have here a system of equations where we have two equations and two unknowns, so we can now solve this problem. To emphasize, here we have the original equations with x plus y equals 60 and 0.27x plus 0.75y equals 0.47 times 60, where c subs of 27 is 27%, or 27 over 100, or 0.27. And then we have c sub of 75 is 75%, or 75 over 100, or 0.75. Finally, we have c sub of 47 is 47%, or 47 over 100, or 0.47. Now we have our two equations set up for the system of equations. First, we'll use x plus y equals 60, and we will use substitution to solve these equations. Here we will solve for y, and we will subtract x from both sides of the equation to keep the equations equal like a teeter-totter. X on the left side will cancel each other out, and we will have 60 minus x. Now we can substitute y with 60 minus x in parentheses, and we put the parentheses because we want to put this 60 minus x into the other equation as part of substitution. So if you think you're learning from me, please like and subscribe to my channel so I can help other people who want to learn as well as you. Thank you if you did like and or subscribe. I remember when I was learning math, I thought at first that it was hard to solve mixture of word problems. But when I learned how to use the table to help me visualize the problem, which helped me then know how to do mixture of word problems. When solving mixture of word problems, it is helpful to create a table to help you solve and visualize the problem, as mixture problems are important for baking, chemistry, nurses, pharmacists, and so forth. These are some questions that deal with mixture problems. So enough of this commercial break, and let us continue to solve this problem. Another suggestion I can give is to get rid of the decimals. True, we don't have to do this step, but some of you may not become comfortable with decimals, and this step will generally make things easier to solve this problem. So we'll multiply each term by 100 to keep the equations equal, like a teeter-totter, and we can shift the decimal place to the right by 2 since we're multiplying by 100. Let's start the equation has two parts to it, so we need to multiply by 100 for each part. Multiply by 100, we get 27x plus 75 times 60 minus x in parentheses equals 47 times 60. On the right side of the equation, when we do 47 times 60, we'll get 2,820. And then next, on the left side of the equation, we can use the distributive property for 75 times 60 minus x in parentheses to be 60 times 60 and 75x. Since we have parentheses, making 27x plus 75 times 60 minus 75x equals 2,820. Next, we can change the minus 75x from subtraction and change it to negative 75 in parentheses times x. Make this addition from subtraction. Then we can place the 27x and negative 75 in parentheses times x next to each other using the commutative property of addition. We can see that the equation is set up to solve after we remove the decimals. We have 27x plus negative 75x in parentheses, or 27x minus 75x, which equals negative 48x. Next, we will multiply 75 times 60, and that will be equal to 4,500. We want to get the unknown on one side of the equation, usually the left side of the equation, and get the number on the other side of the equation, usually the right side of the equation. So we'll subtract 4,500 from both sides of the equation to keep it balanced like a teeter-totter. On the left side of the equation, the 4,500 minus 4,500 will cancel each other out to become 0. On the right side of the equation, when we do 2,820 minus 4,500, and that will be equal to negative 1,680. Now we want to get the unknown of x by itself, so we'll divide by negative 48 on both sides of the equation to keep it balanced like a teeter-totter. What we do to one side of the equation, we need to do to the other side of the equation. And now that we see that negative 48x over negative 48 equals negative 1,680 over negative 48. On the left side of the equation, when we do negative 48 divided by negative 48, we'll cancel each other out, just leaving as x on the left side of the equation. Next, there are the negative numbers on both the numerator and denominator on the right side of the equation, and the two negative numbers will cancel each other out, making it a positive number of 1,680 divided by 48. Finally, when we do 1,680, 48, that will be equal to 35. We have found x to be equal to 35. This is the pounds of milk chocolate that we need, which is 35 pounds. Now we want to find y of pounds of the dark chocolate that we need. Putting this in the original equation of y equals 60 minus x, first we'll substitute x with 35, the pounds of milk chocolate that we have just found. And when we do 60 minus 35, that will be equal to 25, where we have found y equal to be 25, which is 25 pounds of dark chocolate. And we have found that the baker needs 35 pounds of milk chocolate with 27% cocoa, and also needs 25 pounds of dark chocolate with 75% of cocoa. We have found that x equals 35 and y equals 25, or 35 pounds of milk chocolate and 25 pounds of dark chocolate. And we can place the x and y values in the table with these values that we have found, as we can compare the table with the variables of x and y with the values of 35 and 25 appropriately. Now we'll check our answers by plugging in the values into the equation of 0.27x plus 0.75y equals 0.47 times 60. First, we will substitute the variable x with the value of 35 and the variable y with the value of 25. Like we did earlier, we want to multiply all parts of the equation with the value of 100 to keep the equations balanced like a teeter-totter. As we do to each side of the equation or parts of the equation, we need to do the other side to keep the equation balanced, as this will help us get rid of the decimals. When we multiply 100, 0.27 will be equal to 27, 0.75 will be equal to 75, and 0.47 will be equal to 47. As we are shifting the decimal point to the right by 2, we will multiply by 100. On the right side of the equation, when we multiply 40 times 7 times 60 will equal 2,820. Then on the left side of the equation, and when we multiply 27 times 35, will be equal to 945. Next, we will multiply 75 times 25, and that will be equal to 1,875. Finally, when we add 945 plus 1,875, that will be equal to 2,820. Here we have found that the answer is 2,820 equals 2,820, which are equal. This is true. These are valid answers to the question. Now, if we were to try with x equals 35 and y equals 25 in the equation of x plus y equals 60, and then we substitute with x equals 35 and y equals 25 in the equation, we get 35 plus 25 equals 60. Finally, we add 35 and 25, which will be equal to 60, so we get 60 equals 60. This validates the answer for the correct problem. Yes, it's overkill to prove the problem twice, but this does prove that these are valid answers for the 35 pounds of milk chocolate and the 25 pounds of dark chocolate to make the mixture of chocolate. Please remember to use the table to help visualize the data and how to solve word mixture problems, and also to deal with decimals. When the percentages we can multiply by 100, and reading the word problem at least 3 times. If you feel that you have learned something, please like and subscribe, and thank you, and have a nice day.